Hello, gamers. Welcome back to another episode of the Real Hacker Hours podcast. It's been a while since I've done one of these. So currently, what my project that I'm working on is database reversing and exploitation. Effectively, what I'm trying to do is I've noticed a trend among several different database implementations where if let me take a step back. So a lot of database implementations, when they are saving the database, they'll save it to a file. And one thing I've noticed is while it's a bit of an unusual attack surface, if you can control the database file that's being imported, it can lead to some fun behaviors in some instances. And right now what I'm trying to do is this database implementation I'm looking at, I'm just trying to reverse out the insertion algorithm for how it inserts new records to give me some potential insights into what I can do if I can control the database input file. But yeah, with that, let's get going. The database implementation I'm currently working with is called SDB, and I believe, this is looking like source code file. So this particular database implementation, you have the option of importing it into actual C code and calling API functions from the library in order to reference it. Here we can see it with the fact that we are actually setting values within the database. This particular database implementation, now that I'm remembering, I believe it is a sort of like a hash map where it's like a key value sort of system going on. But yeah, I'm going to pull up the source code for the database so I can try and figure some stuff out. Where was it? So the base function for insertion is SDB set. So let's quickly find where that is. Where was this? It is int. Don't think that's sdb.c. Okay, let's open it up. sdb.c. Okay, cool. What is the name? SDB set. Okay, yeah. As we can see from our sample code right here, SDB set is the function responsible for actually setting a value. Which, looking at here, we see that basically just wraps SDB set internal. The arguments to SDB set internal. This SDB pointer, it's a pointer to a struct that effectively just models the database. Key is the key that we're inserting into sort of like a hash map key value. U is the string that we're going to store as a value. Not too sure what these last two operands are, but we'll see if that matters. Okay, cool. So looking at this, oh yeah, by the way, all this documentation I made just regarding the internal workings of SDB. However, due to some other things, I had to take a few days break from this, so I forget exactly what the stuff is. So I'm just going to go through it again. What is val? Okay, value if. Oh, okay. So this is basically just checking if value is set and if it isn't, just setting equal to a string. This here is getting the length of the key and the value and just checking if it's not. Well, if it's greater than these two constants, which I'm pretty sure those constants are just like the maximum size, so it's just doing a max size check against the key and the value, which if we grab through the source code, ASC, so the maximum size of a key is OXFF, and maximum value size is, oh wait, I mistyped that. is OXFFFF, however many Fs that is. Okay, cool. So there's a size check there. This is looking like it's just I'm first time I've seen this, but I'm just guessing what this is this S journal is probably a variable related to logging, and it's basically just saying, hey, are we actually logging? And if so, log it with SDB journal log. And hang on a second. Okay, I'm back. So next up we have CDB find start and SDB HTB find KVP. And it just basically just checks, did we actually find it? And if so, this if then statement executes. So what's going on here? The thing is, when it's inserting, this is just what I'm kind of like speculating from here on, and I'm going to see if this is actually true. When it actually goes to insert a record, there's probably several different scenarios. First scenario is there is no record at where the key is, or where the key should point to, so it just creates a new record and inserts it. Another potential situation is when it goes to actually insert the record at the key spot, there is already a record there, in which case it has to actually deal with that, whether it be deleting the old record, updating it, doing something. What I believe this if-then statement here, judging from the fact that it appears to be searching for the key, is it's just checking, hey, does a record already exist there? And if so, we will deal with it within this if-then clause, which we see that at the end of this clause, it returns from this function. And then this code down here, I believe it's inserting a value at a key spot that there's nothing there, so it's the first time. And when I say key spot, I just mean the spot within a database implementation where the key will map to, because it's sort of like a hash map. So moving on. Okay, now one thing I'm wanting to, again, this database implementation works off of a hash map, sort of like just gonna show a quick one. Yes, just like how in a Python dictionary, and this one that I just made, the key 0 maps to the string hi, something like that. So to actually check if it can find it, calls CDB find start and SDB HT find KVP. I'm not sure what HT, KVP, or CDP are in these contexts, but I'm just going to record these two functions, and then let's take a look as to what they are. Let's see, is this function declared in here? No, let's see, where are they declared? cdb.c. Okay, it just calls elseek, which, let me just, I forget. The first argument, oh yeah, file descriptor. Okay, that's interesting. So the database, because we see here that the argument being passed appears to be the DB, or the address of it, which, actually no. Okay, that's a database struct, or a CDB struct within here, and within the CDB struct is a file descriptor. For a second, I thought the argument actually being passed in itself was a file descriptor. So effectively just calls elseek on the database. Still interesting to see that the actual, looks like the actual thing that points to the actual database is a file descriptor. Okay, and now let's look at this. What is this? I get the feeling this might be here. Okay, it does not appear to be here. Okay, this is interesting. I'm grepping for this function to look for. Oh, wait, actually, that's not it. I'm grepping through the source code to find where this function is, but I'm not seeing a function declaration. Did I find it in here? I think I found it in my docs already. Oh, okay, I understand. So this is the function right here. Reason why I can't grep for it is if we look at the function declaration, specifically the function name right here, the function name itself actually contains variables, so we can't just grep to find it. I believe how I found this function was I just braked at that spot in GDB, stepped in and saw, hey, this is the actual function name being called, and just found it from there. Okay, cool. So yeah, this is the, so perceiving that the SDB function is called to see if it checks for if the key exists in the database already. Okay, cool. So looking at this function, we see that it first starts off, actually, looking at, wait, let's go back to where this is called. So looking at this function, there are 3 arguments. HT, which I'm not sure what that is, HT name pointer, the key that we're searching for, and the address of a Boolean that is set equal to, is this found or not found? First checks, do we actually get a non-zero or a non-null pointer for that Boolean? And if so, set it equal to false immediately. Next up, excuse me. Okay. Next up, it checks is the HT pointer, is it null? And if so, just set found equal to false and return null. So these are effectively just sanity checks to make sure that the arguments are correct. Next up. Okay. So next up, it appears to get the bucket associated with the key. Now, let me explain what a bucket is. Effectively within a hash map. So there are more possible hashes that can be inserted into this hashing algorithm than there are spots for those hashes to map to. As a result, hash collisions will happen. How this hash map, or how many hash maps will deal with that, is they will have a bucket system. So a hash won't map to a particular spot where it will store a record. It will map to a bucket, and that bucket will store the records in it. That way, if you have a hash collision, the hash will map or resolve to a bucket, and that bucket might contain multiple records, but it should contain the record that you have. So it appears to get that. Bucket FN. What is bucket FN? Oh, bucket FN is just hashing it. So it hashes it. Wait, no. Hashes it and then mods it by something. Okay, that's a bit interesting. Appears to do some sort of hashing stuff on the key. Resolve an HT table. BT. Key length. Okay, so it's looking like here, my memory is coming back to me from back when I worked on this a few days ago. Yeah, this right here, the purpose of it is it's getting the bucket associated with the key via hashing and looking up in the array. And here, it's iterating through each item in the bucket and checking to see if the key matches the key stored in the bucket. Now, I think this would be a good idea to, I'm going to pull up the actual database file. What is it called? believe I called it B in this aspect. Okay, cool. Okay, cool. I think this, if I recall correctly, this is how it works. So you have the bucket array. The bucket array is this region up here. It doesn't actually store the buckets, it stores the offsets to the buckets. Now, if I recall correctly, how it works is it will take the key, hash it. The hash will give it the offset within the bucket array to something like, let's say, 4004, and then I'll go to the offset 0x0404, and this will actually will resolve to the bucket. The bucket, actually, this isn't right. This is not right. What is the actual hashing algorithm used? Okay, so this is the hashing algorithm right here. I reversed it out earlier on. Let's go ahead and try this. Def hash STB. I'm just gonna edit this a little bit. X. Okay, let's try out this function. Okay. For this, I can tell from a mixture of my memory, just seeing it here, the keys are key 0, key 1, and key 2. Although now that I'm thinking of it, this database file might have had a few things done to it that makes it not accurate, but we'll see. So let's first hash it with key 0. Offset is this. How do we get... I'm confused. I'll look at this for a second. Oh, wait. I'm going to pause this for a second while I think. Okay, getting back to this, I think what would be the best to figure out exactly how it's located. So, one thing I'm going to want to do is see exactly how it is checking to find the bucket. And I think the best way to do that is to, in GDB, just look at what's going on with the memory in this instance. So let's go over here. I am going to throw this into GDB and see what's going on here. Okay, I'm gonna remove the database file. That way I guarantee that it's a fresh one. There's no weird stuff that I did to it going on. I'm gonna break on STB set. Let's just do that for starting off. Okay, what is the key? So I'm inserting into this. I'm inserting a value, the key being key 0 and the value being value 0. Okay, let's break at STB HT find KVP. This is weird. I was expecting something like this. Wait a second, this calls this other function. Let's continue. Oh, okay, so this SDB HT whatever function doesn't actually call this function. or sorry, this function isn't this function. This function is effectively just a wrapper to this function. That makes sense. And yeah, this code right here is looking similar to this. So I'm just going to step through it. I could just type S, that way I step through the source code instead of the assembly instructions. However, I've noticed a few weird things going on, so I'm just going to step through the assembly code. Okay, now it's calling bucket fn, which will hash the key and then mod it by the size of ht name. I'm not sure what ht is. Might want to figure that out. Let's go in. We see here from our script the hash of key 0 should be 0x7c751342. So let's go in there. Let's see what the return value of here is. 7c751342. Okay, so it is hashing the value we expect it to, but now it's going to mod it by size. So ECX3. It's modding it by 3. What is 2? Is it returning the value 2? Okay, so it's resolving it to the value 2. So it's taking the hash, modding it by, I believe, the size of the bucket. By size of the bucket, I mean the number of spots within the bucket that it can hold and getting that value. Maybe it's that way it can sort of tell immediately where in the bucket that hash would be, but I get the feeling there's more to it than what I'm seeing there. Okay, cool. Moving on, calculate calc size of key. Actually, we're not done with this line of code. We got the return value of bucket fn, which is 3, but I still need to look it up in this table. Shifts it over by 4. Let's just make sure that it is operating the way we expect it. Yep, operating exactly how we expect it to. What it is RBX. Okay, it's adding OX20 to that, so should get 9060. I'm curious. Okay, this, what memory region is this? Heap. Okay. Key 0. What is this calc size function? Let's step into it and see. ht.inc. Okay, let's take a look. What is this function? Change this. There we go. We'll change it to C syntax so it's makes sense. Okay, it just wraps another function call. stir length. It's just returning this length of the key. Oh, x4. Yep, key 0 is 4 bytes long. It's just returning the length of the key. Okay. So key length is just stir length on the length of the key. Then bucket for each. What is this bucket for each? This is a macro, so I'm pretty sure it's not an actual function. Telling it's a macro via the effect that's all capitalized. SDB.c. Yeah, it is a macro. XKB. Well, it's been over 25 minutes. Since this is the first podcast I've done in a while, I'm probably gonna cut it off here. Thank you for watching and see you next time. I should be doing a lot more of these.